Hello everyone. My name is Piotr Kozłowski, and today you will hear about three things that maybe no one told you before. First thing first, we are talking about Agile. Let's have a look at what Agile really is. And Agile is ability to move and to turn quickly and to adapt. For instance, you can say that a boat is agile because it can sail against the wind and turn quickly. But in terms of software development, what is Agile good for? And one of the answers is that Agile is good for reacting to change, to react quickly. So in the software world, reacting to change could mean changing existing features of your system, maybe adding new features to your system, or changing anything else, because requirements that you've got today will change tomorrow, and you can be certain only about one thing, and this one thing is changes. So, one of my favorite questions that I like to ask people, and if any of you goes to any job interviews as a candidate, it's a great question as well. Are you agile? Is your company agile? And if you ask this question to any of the company, the answer will be, sure, of course we are agile. We do sprints, we do stand-ups. We have Scrum. You may even hear that they are following principles and values of Agile. They do estimates in story points and lots of different stuff. But the follow-up question is: does Agile work for you? And the answer here, very often or much too often, is sort of. Right? Agile promised us as an industry a lot. Agile promised teams that deliver on time, but this is not always the case from the practical point of view. So nowadays, I have a feeling that our industry is suffering a kind of hangover. We had really high expectations. The bar was very high. But in the end of the day, there is still friction and miscommunication between agile teams and stakeholders. Stakeholders may expect deadlines and commitments, and all the team has to offer are story points and priorities. And still, teams don't deliver on time. But how come, right? Everyone knows what Agile is. Everyone is very well trained in Agile software development. And myself, I have attended some trainings, formal trainings on Agile, targeted at developers. And in one of these trainings, in a major company working in electronics business, this is what we were doing. We were building houses from Lego bricks. And, it was a lot of fun. It was great. And during this exercise in building houses from Lego bricks, we learned something about cooperation, something about communication, estimations in a team. So it's valid. In our training, in a different company, we were throwing balls at each other and trying to optimize or maximize the number of passes. Also, a great game which teaches you about retrospectives and optimizing your work. In our activity during an Agile training, untangling a human knot. Again, this was about self-organizing teams, and this was about how a team that organizes itself could organize the work better than a single person, single leader telling everyone what to do and what not. But definitely there is something missing here. because everyone is trained very well. Everyone accepts the principles of Agile. Everyone accepts for instance, Scrum ceremonies we've got. But if you have a closer look, you will notice that most of our Agile trainings are run by, let's call it business people, by Agile coaches, by project managers. So the focus of most of the trainings is on the process and not on the code itself, right? So today I'm going to show you three very maybe obvious, maybe simple things, three puzzles that match beautifully with each other and fills the big picture of Agile. And the thing number one is clean code. Why clean code? You need clean code to enable agility, right? If your code is clean, then you are able to modify it at ease. You are able to add new features to it and to change what is already there. And in fact, we've had a talk today about clean code. We have in our talk, lunch talk tomorrow about simplifying your code base. So I really encourage everyone to attend. And you know what clean code really is. There is a number of definitions coming from different people, but the common part is that code that is clean is code that reads well. Clean code is no surprising. If you see a routine, you know what it does just by name, for instance. Clean code is covered by tests, has no duplication, is well designed, and so on and so forth. So once you have clean code, you could be agile. But the problem is that clean code is not granted. It's not given to you. It's your job as a developer to make the code clean. And you know, some very talented, gifted people write clean code at the first try. And you know, to be honest, I'm not one of those. I have to iterate. And sometimes even start from scratch, do git reset hard and start again. More often, what I do is I write something and then I refactor. And this is the takeaway number 2. Refactoring. You need to refactor to have your code code clean. And what is refactoring, by the way? Refactoring is changing the structure of your code, the inner working of your code, without changing the existing features and without affecting performance. So. For instance, think about your definition of done. If there is a step in your definition of done, saying, well, you know, task is complete when the code is refactored, I've got bad news for you. You shouldn't put refactoring as a separate step. It's obvious that you have to refactor to clean your code base. But you know, playing with the code could be tricky because when refactoring, you may accidentally break something, and this happens if you are fiddling with functions here and there, flipping the if conditions or whatever. And well, how to ensure we'll not introduce any defects? Well, the answer is tests, and more precisely, test-driven development, right? I guess most of you know what it is. There are just 3 simple principles in test-driven development. You start off with a failing test, then you provide a minimal implementation, and then you refactor. So test-driven development, in a way, glues together clean code and refactoring. And you know, in the early days of test-driven development, there were some serious critics. There were articles saying that, well, you know, maybe this won't work, but at present, we've got academic research showing that TDD just works. If you do TDD, your defect ratio will decrease at a cost of 10 to maybe 20% time increase of delivering something. But the bottom line is that TDD works, and everyone needs to get over it. Full stop. So the question is how to learn these things, and the simple answer is practice, right? Do coding dojos, do katas, practice your coding skills. And by the way, working is not practicing. When you work, your mindset is different than when you practice. When you work, you are focused on a result. You are focused on delivering on time. When you practice, you focus on trying new ideas, trying new ways to work, and you focus on how you do things, not what is the result. If in some input, there are great books out there, Clean Code by Uncle Bob, Refactoring by Martin Fowler. There was a book recently published called Growing Object-Oriented Software Guided by Tests by Price and Freeman. I highly recommend these books. Or alternatively, if your company offers trainings in these areas, do attend. So to wrap it all up, the first level is test-driven development. Use it, and then you will have well-designed and testable code. Then on top of that, you go with refactorings to make your code cleaner. And once you have clean code, you are enabled to react to changes in a quick way. And only on top of this, build other process-related agile stuff like sprints, story points, retrospectives, and whatnot. So some image credits, and thank you very much for your attention.